Yeah, okay. Hey everyone, welcome back. We have another speaker here, Poornima. Welcome. When was the last time we saw each other? I think it was not in the Netherlands. I think it was in Romania, I think, right?
Yes, that's right.
The .NET days. That was also very nice.
Yes,
Yeah.
it's good to meet you again.
Yeah, exactly. Great that you're here. So you're combining virtual Azure Community Days with another conference, right?
Yes. So tomorrow we have another stream from the studio. So I'll be hosting tomorrow while I'm a speaker today.
Nice, excellent. Okay. And how have you been doing the last couple of months?
It's been good.
Yeah?
Busy.
Mm-hmm.
We had a break for Christmas, and here we are, 2023, and today is my first talk of 2023.
Nice.
And it's my first time at VACD as well, so I'm really
really?
glad to be here.
Excellent. Okay, yeah. Well, we're very excited to have you. I would say feel free to go to your laptop, and yeah, we're very excited to hear about your session with GraphQL, and of course, one of my favorite subjects.
Of course.
Azure Functions. So I'm super curious.
Absolutely. Let me see if I can make you more intrigued with my session now.
Oh, you definitely will.
Okay,
all right. Well, she's preparing. If you want to contribute to next Virtual Azure Community Day, always keep an eye out for our CFP. If you can do a session, we're always happy to help you prepare with your session or do some rehearsals, or maybe you want to co-host like I'm doing today. So always feel free to reach out to one of us. All right, I think we are ready.
Sure. Hello and welcome. I will be talking about GraphQL and Azure Functions today. How can you get a GraphQL server running on Azure Functions? That is my topic for the day. Thank you for having me as a speaker at VACD today. I'm excited, but let's not waste any time. Let's get started. Before I start off with the topic today, my name is Poornima Nayar, and I'm a freelance .NET developer. I live in Berkshire, United Kingdom with my little daughter who is 8 years old and my husband. I'm a Microsoft MVP for developer technologies, and I'm also an Umbraco MVP. For those who don't know what Umbraco is a .NET-based open source CMS, and I do a lot of work with Umbraco. And non-work me, I'm a mother. I read a lot. I'm also a singer. I am training in Carnatic music, which is a stream of Indian classical music. And that's my Twitter handle should you wish to connect with me. I am not on Mastodon yet. Okay, talking about GraphQL. GraphQL was introduced to us by Facebook back in 2012. So it's nearly 10, 11 years old. So more than a decade old. And Facebook engineers came up with GraphQL as a solution to save their app, the Facebook app, which came out in 2012, which was struggling with draining the battery life of your device, slow startup, lots of bandwidth usage on your mobile device, all sort of problems. GraphQL was what Facebook engineers came up with as a solution. But what exactly is GraphQL? It's a query language for your API. So unlike REST, which is an API in itself, you could say that, GraphQL, a part of it is a query language. So you query your APIs. So straight away there you can see how the control shifts from the server to the client because you're querying your API. And that is part A. There's a second part to it, which is a runtime on the server, which understands, parses, and executes and validates your GraphQL query. And that's a server-side runtime. And all this happens on top of your existing data layer. Your data might be in a database. It could be coming in from a REST API, a third-party REST API. It could be a collection of GraphQL endpoints as well. GraphQL is very effective in acting as a gateway on top of your existing data layer. So it's query language for your APIs and a runtime for fulfilling those queries. And what you get with GraphQL is a single but smart endpoint, because what it does is it takes complex queries and builds the data output for you. And what I mean by that is, if you have a look at my example here, where I query the hero, I'm asking for the name of the hero, and then I'm asking, I want hero's friends as well. But for the friends, I just want the name. I'm not interested in any other information about the hero and the friends. The hero might have an ID field, a description field. The friends might have an ID field as well, but I'm not interested in any of it. I just want the names. And if you see the response that I get back from the server, it's JSON. My query is JSON-ish. But what I get back from the server is JSON. But if you look at the response quite keenly, it's a mirror image of my query itself. So developers benefit from that predictable response from the server. I'm also asking for related information here. I'm asking for hero and the friends. In a typical REST world, what I would get is hero and some IDs for the friends. But with GraphQL, I can ask for related information as well. And moreover, if I ask for something from the GraphQL server, I only get what I ask for. I don't get anything more than that or less than that. So in a typical REST world where the API says, just call me, I'll give you everything that I have, GraphQL is all about, hey, tell me what you want and I'll fetch you exactly that. So there's no data wastage there, which is the reason Facebook engineers came up with this kind of pattern. And as you can see, the client is in control of what they ask for. The responsibility shifts from the server to the client, which is very, very valuable for mobile apps particularly. Talking about Azure Functions and why it is good to have, or why GraphQL and Azure Functions are a good match, as we all know, Azure Functions is a very versatile product offering from Azure. Of course, it leads the serverless computing model. There are servers, but as developers, like I'm a developer, I don't get to see any server management or configuration. But at the same time, I don't need to worry about availability because high availability is assured to me. Azure Functions can scale on demand, so it can take up load and scale. And while all this is happening, I still pay only for my usage if I start off with the consumption plan, which is incredibly useful. And me particularly, as a developer, I can focus on application logic. This is really, really important because GraphQL is an application layer. As I explained before, it sits on top of your existing data. So it doesn't concern itself about where the data is. It acts as the application logic, which is what I get to focus on. That is Azure Functions and what it brings. Talking particularly about GraphQL, we have a loosely coupled client and server with GraphQL. That is by its nature. And that also means that the client and server can iterate rapidly. What we also have is exact fetching of data with no wastage of data at all, which is even more important considering the fact that we are on cloud and we are using a model where we pay only for what we use, which is fantastic. And moreover, we have GraphQL, which is an application layer, which can be useful to aggregate data from multiple sources to a single endpoint. And this is one of the most well-known real-world use cases of GraphQL. You aggregate data from multiple sources, bring that as an application layer, and your clients talk to that application layer. And when you bring the two platforms together, that is Azure Functions and GraphQL, what you achieve is your business layer, which is separated from application layer in the cloud. And we are moving a step closer to the resilient, scalable cloud-native architecture, which is the modern way of building applications these days. This also means that we can benefit from simplified deployments, we can iterate at our own pace, and we are moving towards that modern, scalable architecture that I told you about. We need to cover some more GraphQL basics before we move on to the demos today. So we spoke about GraphQL and how it can help you fetch data from multiple sources or even fetch related information. What helps GraphQL at the heart of this is something called the schema. So GraphQL gets its name from the fact that your object hierarchy, the relationship between the objects, that is visualized as a data graph by GraphQL. And you extract parts of that data graph by querying. That is why we have the name GraphQL. And what helps GraphQL achieve this is something called the schema. This is the type system in a GraphQL server or a GraphQL API. And anytime you build a GraphQL server or GraphQL API or even run it on an Azure function, what you're trying to do here is establish that schema. Let's see how and what makes up a schema. So schema is made up of types. The first one is the object types, which is a representation of your object. It can be a person, it can be a vehicle. Examples are many. Then you have your operation types. There are 3 root operation types, starting with queries, which is for reading data. So I can read information about a person or get information about a list of persons or even read about a random person from my API. That is queries. Then you have mutations. As the name suggests, it stands for a change. So it can be inserts, updates, or even deletes. And then you have subscriptions, which is for real-time capability. So if you want to have real-time capabilities in your system, subscriptions is a standout feature which you can benefit from with GraphQL. So these stands for pushed updates from the server. So rather than your client polling for information, server pushes the information to you. And these 4 types make up the types of the schema. So schema is all about visualizing and establishing the relationship between your types, be it the object types, queries, mutations, all of that. It visualizes it as a graph for you. Schema doesn't concern itself about where the data is stored. It is all about that data hierarchy and visualizing that data graph. This is one of the key reasons why GraphQL acts as an application layer. One of the key things to understand with the schema and the types is that types are made up of fields. So query types, mutations, object types, subscriptions, they are all made up of fields. And each field has a name, which is the name of the field, a type, which the field kind of resolves to, like a data type, and what is called as resolvers. So resolvers act as the bridge between your field and where the data is stored. So resolvers are responsible for converting your field into concrete data. So on your object type, the fields might be like ID and a name. For your queries, you might have field like get a person or get a random person. For mutations, you might have fields to say add a person, which is exactly what I'm trying to do today. So what you do with GraphQL querying is you ask for specific fields on specific types. So when I show you the queries that I've written today, you will understand what this actually means. It's all about types and fields. This is the simplest way if you ask me to define GraphQL. GraphQL is also a specification, which means that it is like a contract or a blueprint, and there can be implementations which confirms to that blueprint. So this also means that across various different programming languages, there are various implementations of GraphQL which confirms to that specification. When it comes to .NET, because I'm a .NET developer, there are 2 implementations, GraphQL.NET and Hot Chocolate. Both are open source packages. And in my demos today, I'll be focusing on Hot Chocolate. So we'll look at the first demo for the day, which is all around queries and mutations. And before that, we'll need to have a little chat about Azure Functions and the isolated worker process model. So this is an execution mode in Azure Functions, which was introduced, I think, somewhere in 2021. And this is quite different to the in-process model of Azure Functions. With the in-process model, your class library function is a DLL, which is loaded into the memory of the Azure Functions host, which is your runtime, functions runtime, and it runs within the same process. This means a very tight coupling between your function and the Azure Functions host. But with the isolated worker process, what you actually have is a console app, and the Azure Functions host communicates with your console app. So there's no more tight coupling between your functions runtime and the functions. What this also means is that you can run your function in a completely different .NET version when compared to the host process. So this was the model which Microsoft came up with when they wanted to support .NET 5 on Azure Functions, because .NET 5 was the first non-LTS version of .NET. And going ahead, the isolated worker process model would be the one used for non-LTS versions. So currently, if you want to build a .NET 7 Azure function, this is the execution mode that you need to go in for. But as far as I understand from the roadmap, this is also going to be the future of the execution mode when it comes to Azure Functions, because once this execution mode achieves parity with the in-process model, there could be a time when the in-process mode could be phased out. But what you get from this execution mode is full control over the function startup. There is no more conflict of dependencies. You get dependency injection. You can inject custom middleware. You can benefit from the ready-to-run AOT, which helps you with the cold start. But overall, for me as a developer, it also gives me that developer experience, because I'm getting to work with the builder, the dependency injection, the middleware, all of that. So let us see this in action now. So I've got an Azure function set up here. So this is an isolated worker process model. It's in .NET 7. And I've got this package called Hot Chocolate Azure Functions Isolated Process, which helps me with Azure Functions and the GraphQL integration. So my API is all about a little get person around people. So my model for the day is a very simple person Pogo class, which is here. It's got an ID and a name field. So here, there are some conventions kicking in, which Hot Chocolate helps us with. We spoke about types, fields, and resolvers. So in my case, the person class, that becomes my object type person. And all the public properties that I have here becomes fields on that type, and the getters becomes the resolvers. So that is Hot Chocolate conventions kicking in and helping me write as less code as needed to get going with a GraphQL server. So that is the object type. And to provide data and access to data, acting upon data, I've got this repository called person repository, which has a in-memory list. And I've got some methods which act on that in-memory list. Now we can start thinking about my query. That is the GraphQL query operation type and the fields on it. For it, I set up a query class with a few methods. So there's a getPerson method which gets a particular person from the repository, and a getPersons method which gets all the persons from the repository. And the method names here, the getPerson and the getPersons, becomes the field names on the operation type. So if you're thinking about my query, the fields would be called person and getPersons. That is again Hot Chocolate conventions kicking in and getting rid of the suffix, the prefix get or the suffix async. And you might have noticed there's the person repository here injected directly into the method. So this is called resolver injection, and that is one of the best practices when it comes to Hot Chocolate and GraphQL. The reason being your query operation type, the mutation operation type, the subscriptions, all these classes are singletons. So your dependencies would also become singletons if you do a constructor injection. So you have to go in for resolver injection. So having an argument like person repository and marking it as service would mean this particular repository needs to be resolved in the DI container. And you can also have arguments coming in. In this case, the ID comes in from the GraphQL query. So that is query covered. Similarly, we can have a mutation class. This time I just have one method, which is to add a person. I have the person argument coming in from my GraphQL query, and again the person repository injected using resolver injection, which I'm persisting to the in-memory list here. Now we have to wire this all up. As I said, in the .NET isolated process, we get access to the program.cs and a builder. So I have this add GraphQL function extension method, which is given to me by Hot Chocolate, that sets up the integration between GraphQL server and Azure Functions. And inside that, I can customize the options. So I'm adding my query type. I'm specifying that this particular class acts as my query operation type. And this particular class, mutation, acts as the mutation operation type. And I have a singleton person repository injected into my DI container. And finally, if I look at the GraphQL function itself, I've got a GraphQL executor here. What happens here is the HTTP request data that comes in, which is like a representation of the HTTP request sent in by the Azure Functions host process, that comes in, and that request gets forwarded to this GraphQL request executor. And that executor takes care of executing the GraphQL query and returning the result to you. But that's not more. If I look here, there's a little bit of thing happening in the route. The reason being, once I have Hot Chocolate set up, what it also gives me out of the box is an IDE, where I can test my queries, have a reference to the schema, etc., as you will see shortly. And having this slug as a part of the route helps with the JavaScript and the CSS of the IDE that comes in with Hot Chocolate. So let's see that in action. So let me bring the project up. Hopefully it runs. So that is 7217. So if I browse to the URL, because HTTP GET is allowed, this is what you see as the IDE. This IDE is called Banana Cake Pop. Again, it's from the house of Chili Cream. That is Hot Chocolate. I have a schema reference here, so I can see my query, mutations, all of that. This is all done by GraphQL out of the box for you, because GraphQL has a feature called introspection, using which it can query itself. So I've got some queries here. I'm not going to dive deep into the writing of queries as such, but I want to get a list of persons here, get their ID and name. I can run that, get the names. If I run the query for getting a particular person, I can do that as well. Now, if I want to add a new person, I have a mutation query here. I have specified a variable called person with the person input type, which is the input type that goes in as the argument to my resolver. And I'm using the add person field, setting the variable value to the person argument, and mutations are generally followed by a fetch as well. So there's a change which goes in, followed by a fetch, which means I can fetch the details of the newly added person. And to send the value of the variable, I'm using a dictionary here in the variables, where I send in the ID 3 and a name. So I can see that in action as well. So that is added. And if I now go and run my query for all persons, I should have the newly added person in there as well. So that is queries and mutations. That is GraphQL Server running on Azure Functions, a little primer. And if you're looking at how the architecture looks like, so you can have your wide variety of clients like browsers, IoT devices, tablets, mobiles, connecting to various instances of Azure Functions that run smoothly. And your backend can be a database, a REST API, GraphQL, which can scale on demand as well. So that is a little introduction to queries and mutations. Let's talk about subscriptions now. So we need to understand subscriptions a little bit here, because subscriptions stands for pushed updates from the server to the client. So clients can say, hey, I need updates whenever a person is added. So in that case, whenever a person is added, the subscription system in GraphQL sends the updates to the client. And for that, just like you have resolvers in queries and mutations, you have resolvers in subscriptions as well. It's that resolver which does that work for you. So the resolver should get the information that a person has been added, and that is taken care of by events that are triggered. So when the subscription, or when an event is triggered saying a new person has been added, the subscriber resolver kicks in and sends the update to the client, all the subscribed clients. Typically in GraphQL, that is facilitated by mutations. So whenever a new person is added, it triggers an event saying, hey, I'm triggering an event saying a person has been added. That event is caught by the subscriber. The resolver kicks in and sends the updates. So as you can see, there's a little pub subsystem going on in that place. So in my example, what I'm doing is, whenever a person is added to that list, I want to send an update to the client. And for that, I take advantage of a new event that I fire every time there's a mutation, which is called person added. So for this, I have to use an in-process model Azure function, because there's no support for the isolated worker process model subscriptions with Hot Chocolate at the moment. I think that is, as far as I understand about it, it is all due to the lack of clarity, where you can have streaming from the isolated worker process model. But what I've done here is, I've set up an Azure Functions project in the in-process model, and I have the package called Hot Chocolate Azure Functions installed on it. And I've set up the same exact GraphQL function or the server that you've seen before, that is the person, query, and mutation. But in the mutation class, what I have done is, whenever I persist to the database, there's another little task that is happening. There is something that I send using the topic event sender. So for this, I'm using something called the iTopic event sender, which is again resolved from the service, which kinds of pushes an event or publishes to a topic with a topic called person added. So that is a terminology used in the PubSub world. You publish into a topic, and that is the topic name, person added, and I'm sending a bit of payload with that publishing as well. In this case, the newly added person is sent as a payload. And I've got my subscription class here, which is no different from query or mutation. But in the subscription class, I've got a resolver and that resolver method has a topic called person added. This actually specifies that this subscriber resolver that kicks in whenever there is something published into this topic or with this topic name. So we are publishing using this topic. So which means that every time there is a publishing happening to this topic, something happens here, this subscriber resolver jumps into action. And of course, the payload that comes in from the mutation, that is captured into an event message, and I return that person back. And talking about the startup, wiring it all up, I again have the add GraphQL function method, but I need the add subscription type and specify my subscription class. And I also need some kind of a provider for my subscriptions because we are talking about a little pub subsystem here. For demo purposes, the in-memory subscriptions will do, but in real life, we need something like Redis, which can scale and make sure that between your Azure Functions instances, the pub subsystem synchronizes. I'll show that to you in a second. And the function is no different. There's the GraphQL executor to which my request data is forwarded to. So in process, let us run that and see now. That should run 7216 here. So I've got the same queries here, but I've also got a subscription called add person. I'm going to start my subscription and the server it's going to listen to the server. So if I now add a mutation in saying new person added, I should get that information quite readily here. So let's change this to 4. And if I run this again, I get that information straight away here. So that is subscriptions in action for you. And this is how the architecture can look like. You have your Azure Functions instances, which talks to your backend server, again, REST, GraphQL endpoints, database. But you would also have something like Redis, which acts as your subscription provider. So this means that if you have one client connected to function instance A and one connected to function instance B, if there's a mutation coming in on function instance A, the Redis fan out mode make sure that the mutation triggers the event, and that event is then passed along to all other function instances, and all the connected clients can get updates from the Azure Function instances. There's one more thing here. Subscriptions usually work on WebSockets, but socket connections to Azure Functions is not possible. So you have to use something like GraphQL SSE, which is well supported by Hot Chocolate to communicate over subscriptions with the Azure Function instances. So what happens with GraphQL SSE is it is it is a package, or it is a facility that is built on top of SSE, that is Server Sent Events Protocol, which stands for a one-way communication, but long and persistent from your server back to your client. So it is built on the native SSE protocol. So that is it from me today. That is a quick start to GraphQL over Azure Functions. This short URL will take you to my blog, which I've written about everything in detail. And a big thank you to Michael Stabe, who helped me with the subscriptions and answering the questions on it. Thank you very much. Hope you enjoy the rest of the day.
All right, great. Thank you very much, Poornima. Let's have a brief chat still here. Maybe need the next speaker can get ready. This was very. I liked all the code samples, very clear and concise. Definitely, I haven't touched GraphQL myself yet. I was really surprised that it's already like 10 to 12 years old.
Yes,
I did not realize that.
Yeah, okay. Absolutely. It is quite new, but it is gaining traction from what I can see. Yeah. Especially in the .NET realm, with Maui becoming so popular. I see this becoming more and more popular and gaining more and more traction. What I've done is scrape the surface of GraphQL today, because once I started learning more and more about GraphQL, just because I liked learning about it, it is so much. There is so much to it than what you see on the surface. Yeah, indeed. And of course, there is a steering committee which decides where to go. Right. I can talk more about the streaming and differ functionality, which is similar to subscriptions, but hey, on another day.
Another conference, exactly. I'm definitely going to ask you, maybe we can work together on some kind of lesson for Azure Functions University, because I think this flows in very nicely with the stuff that I've been doing so far. So let's elaborate on that.
Absolutely.
All right.
Thank you.
I think we're almost ready. So thank you very much, and see you soon.
See you soon.
All right. I think it's time to welcome our next speaker, and that's Esther.